In this lab, we will continue with the visualization of hierarchical clustering um, for the uh, for the data set found me. Uh, we will compute the adjusted random indices for k equal to 9 clusters produced by the complete and the single linkage method respectively. Let's find the pairwise Euclidean distances and let d equal distance of found me, and we need to exclude the column cluster class because that is non-numeric column. Let's use the complete linkage method. It is by default, so we don't have to put method equal complete. Let r equal h cluster of d, and that gives h cluster of d equal d. Cluster method is complete, distance is Euclidean, number of objects is 1000. Adjusted random index by complete linkage method. Let ARI equal 8. So there will be 8 values of 0 in the array. For k in 2 to 9, so k equal 2, 3, 4, 5, 6, 7, 8, 9 curly braces. Let ARI of k minus 1. So this starts from the value in the position 1 in the array ARI, then it goes up to position 8 in the array ARI, and that equals adjusted rand index of s dot integer of found me at class comma cut tree bracket r comma k. So that will this will measure the similarity of found me at class to cut tree of r comma k. Close the curly braces. Printing ARI gives these values. Now for the maximum, we want the maximum similarity, and that is from the first value for k equal 2. From the complete linkage method results, all the similarity values are very close to 0, showing that there is random allocation of observations into each partition. The highest similarity is from forming of 2 clusters. The lowest similarity is from forming of 4 clusters, 2, 3, 4. Complete linkage by default. Let so r equal h cluster of d, and we don't have to say method equal complete because that is by default. And distance is measured using Euclidean method. Names of r, so r will give us the values of image, height, order, labels, method, call, and dish dot method. Dendrogram, so to see the dendrogram we pass the command plot bracket r. Comment: at the very bottom are all the observations. Moving from bottom to top of the dendrogram, the furthest observations are linked first into a cluster until there is one cluster at the top. Let's plot the clusters. So we know that for k equal 2, the cut tree equal 2 gave the highest similarity to the observed values. Let's have a look. So par bracket mf row equal continuous bracket 2 comma 2, that is two rows and 2 columns. For k in 2 colon 5 plot. So we are looking at v1 and v2 variables. Color equal cut tree r comma k plus 1. So cut tree is r, and we cut tree k equal from 2 to 5 and plus 1, that will give us the color. Main equal page t is 0 and bracket k equal and then the value of the k, and c x equal 2. This is the size of the uh, points. K equal 2. So this is the best cut that we can get according to the IRI, which is adjusted rand index. And k equal 3 is this one, k equal 4 and k equal 5. So we can see that from these plotted clusters, k equal 2 gave the best clusters. Comment at the very bottom are all the observations. Moving from bottom to top of the dendrogram, the furthest observations are linked first into a cluster until there is one cluster. We don't need this comment. Pairwise Euclidean distance. Now d equal distance of found me excluding the class column. Now we use the single linkage method to find the tree, the hierarchical clustering. So let R1 equal H cluster of D, comma, method equals single. That gives H cluster of D equal D, comma, method equals single, cluster method is single, distance is Euclidean, number of objects is 1000. Adjusted rand index by single linkage method, let ARI equal 88. That gives 8 values of 0 in the array. For k in 2 to 9, so k equal 2, 3, 4, 5, 6, 7, 8, 9. Let ARI of k minus 1. So this is from the position in the ARI array 1 to 8 equal to adjusted rand index of s dot integer of found me at class, comma, cut tree of R1, comma, k. So R1 is the hierarchical clustering, and we're cutting it accordingly for k in 2 to 9. And printing ARI gives these values. To find maximum of ARI, we pass the command max of ARI, and that is 0.0143996, and that is for k equal 2, 3, 4, 5, 6, 7, 8, 9. Very last one for k equal 9. So k equal 9 gives us the highest similarity to the observed value. Let's have a look. From the single linkage method, all the similarity values are very close to 0, showing that there is random allocation of observations into each partition. The negative values of similarities, so we have two negative values of ARI, that is for k equal 2 for cutting into 2 clusters and cutting into 4 clusters. The negative values of similarities of forming 2 clusters and 4 clusters shows that the results are orthogonal or complementary. The highest similarity is from forming of 9 clusters. The lowest similarity is from forming of 2 clusters with the orthogonal results. So names of R1. So R1 has the values of these names. match, height, order, labels, method, call, dished dot method. And plotting the dendrogram, plot R1 gives us this dendrogram. Comment as moving up the dendrogram with a single linkage method of hierarchical clustering, the close observations are linked first until there is almost no gaps in between observations. The minimum distance pairwise dissimilar observations are fused into a cluster. Let's do some plotting of the clusters. So per MF bracket, MF row equal continuous bracket 2 comma 2, that gives 2 rows and 2 columns. For K in 6 to 9, so K equals 6, 7, 8, 9. Plot bracket V1 comma V2 comma color equal cut tree of R1, so the single linkage method, the tree created by single linkage method, R1 comma K. So K will be the cutting of the tree, comma main equal paste 0 of K equal K, comma CX equal 2. The CEX equal 2 is the size of the points as well as the labels, size of the points. So we know that from the graph the maximum similarity came from K equal 9. So let's have a look. So this is for K equals 6, K equals 7, K equal 8, and this is K equal 9.